Well, over the weekend, there was a massive solar storm, saw huge amounts of magnetic plasma being ejected from the sun. The entire solar system, including our Earth and our planet Earth, was affected. It caused a lights festival in the sky at night in the southern and northern poles. But this kind of event can also disrupt certain communication systems and even power grids. Professor Lerothodi Leeuw is an astrophysicist at the University of the Western Cape. Professor Leeuw, good afternoon to you. Nice to talk to you again. What's happening on the sun, in the sun, do I say in the sun, on the sun, when these lights are being seen on Earth?
Hi, Stephen. So the sun, we all know, emits light as well as heat. But in addition to this, the sun also emits electrons and protons. And in science, we know that when you have electrons moving, you also have a magnetic field. So there is an internal magnetic field that also comes with this. So normally it's just emitting this and we call it a solar wind. But sometimes this solar wind intensifies into this big, massive ejections that we call a solar storm. And this is what happened this weekend, yes. These then interact with our own magnetic field. Our magnetic field goes from north to south. And close to the equator, usually our magnetic field will shield us from these fast-moving electrons that come from the sun. But when there's a big storm, then there's even more of these. They come streaming into Earth through the poles. And typically then they heat up our atmosphere. And this heating up causes molecular gas in our atmosphere, oxygen and nitrogen, to emit these lights that we saw this weekend.
So why only at the northern and southern poles? Why are we closer to the equator being excluded?
Okay. So it's because the magnetic field itself runs all the way from from the pole, from each of the poles, and it's much bigger in the equator and does the shielding there, but the particles then stream into the atmosphere through the poles. So typically the auroras are just concentrated at the north and south poles, and we have what we call an aurora oval that will appear just like a little ring in the north and south poles. So they are strongest there. But when there's a magnetic storm like we just saw, then this concentration is not just in the north and south poles, but goes to the latitudes away from the poles as well.
Okay, and we have a magnetic field because we have a lot of, if I've understood it correctly, a lot of iron in the center of the Earth. We have a lot of metal in the actual core of the Earth, which is rotating. So it's a bit like a magnetic engine. If we didn't have that, we'd be in big trouble, right?
Yes, yes, indeed. I'm very, very impressed with that explanation, which actually gives the origin of our magnetic field. And indeed, one of the functions it serves is to protect us against these particles from the sun. But we also now use it for navigation. You humans use it for navigation as well as animals. So this magnetic field play these many different roles. And this weekend, we learned that one of the roles it also plays is to create these magnificent, lightning displays that were seen all over the world this weekend.
So what is happening in the sun? So the sun, as I understand it, is made up of helium and hydrogen. They interact together and they have continuing sort of nuclear reactions. So then why is it that that nuclear reaction, which I would imagine is kind of constant, why does it have sort of storms?
So you described the magnetic field around Earth. It turns out the sun itself has a complex magnetic field similar to the one on Earth, and also caused by a dynamo, in this case a dynamo inside the sun. and this magnetic field around the sun is ever changing. And sometimes when you have these tangled magnetic fields at the surface of the Earth burst open or split, then you have this kind of magnetic, ejection of ejection as well of these masses of electrons and particles that come towards Earth. So it's because the sun itself has this magnetic field, and it's when it's these tangled fields either untangle or tangle that disruptions can occur.
Can we predict that this is going to happen? I mean, there were warnings. I know we have a space weather observatory as South Africa. How do we predict that something like this is going to happen? And as I understand it, the sun actually runs on an 11-year cycle.
Yes. So there's an 11-year cycle that when it's very active, is active for 11 years and then is less active for another 11. We call the big activity solar high and low activity solar minimum. However, these massive ejections will they happen mostly during solar high rather than minimum. However, they can also happen during solar minimum. So the cycle helps us predict when the ejections would be likely, but it's really, really unpredictable. And the only way we can predict is by watching when the buildup might be occurring. And then the particles in a storm might will typically take between a day to 4 days to reach Earth. So in the best cases, our prediction can be, a day to 4 days from when it was first observed to be occurring.
Thank you very much indeed. Really do appreciate it, Professor Lerothodi Leeuw. So much to talk about, Professor of Astrophysics at the University of the Western Cape.